All right, so if we take a look at this problem right here, you have to be really careful of how you are drawing this, because if you, oops, I'll rebroadcast it, just give me a second. All right, so with this problem, you have to be careful with the drawing, because if you draw this incorrectly, you're not going to see the relationships that appear. Okay, so you have this circle ABC with a given area. Okay. So this is the area of our circle is 90. Okay, and we're told that this arc measure from A to B is 65 degrees. So this angle, or this arc measure right here, is 65 degrees. Notice I drew it relatively to scale. Okay. And then the arc measure from B to C is 59 degrees. So that's, oops, here's C. So that's even a little bit smaller. I once again drew it a little bit to scale. And the whole reason for this is you need to be able to see that triangle ABC doesn't cross the center of that circle. Okay. It stays on one half of the circle itself. Okay. Because what we're looking to do is we're looking to find what is the area of this triangle right here. Okay, so in order for us to find the area of that triangle, what we can now do is figure out some of the other parts of this figure. Okay, all we know is the area of the circle itself. Well, the area of a circle is pi r squared. So if we wanted to find the radius, we could divide by pi, extract the square root to get our radius. So the radius, I'm going to go ahead and calculate that, is the square root of 90 divided by pi. Okay, that's all inside my radical. And I do want the decimal form for this. I'm going to hit the green diamond. Okay, so this is my radius. My radius is approximately 5.35. All right, so here's where the radius comes into play. And it's something that you just have to kind of be able to create on your own. It wasn't there from before. Okay, but you now know that these two radii to points A and C from the center of this circle, okay, are 5.35. Okay. Do you know what this central angle is between those two radii? You have an arc measure of 65 plus another arc measure of 59. So what is that total arc measure going to be? If we add those together, we get 124 degrees. And so now if you look at this triangle formed from the center to points A and C, we don't specifically have length AC in triangle ABC. We don't have any length in that triangle, but we can find length AC by using this pattern right here. We've now created an isosceles triangle. Right, the isosceles part being the radius, the radii of the circle. Okay, and so what we can now do is I'm going to call this x. We're going to solve for distance AC, which is x. Okay, so we have this SAS pattern. So SAS tells us we're going to use which law? Oops. So SAS tells us we're going to use the law of cosines. Okay, so we can find x. That side squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides, all times the cosine of this angle opposite our unknown, the 124. Okay, so here's the calculation that we're going to use. So I'm going to highlight this measure. I take the square of that, add it to that value squared once again, subtract 2 times that value times, again, that value, all times the cosine of 124. Okay, and I hit enter. This is my x squared value. My x squared value is about 89.3. I extract my square root, so I'm going to take the square root of that number. and I get x to be approximately 9.45. All right, questions on how I got to any of this stuff before I move on? Does everybody see that process that was used there? And,
Are we going to, so as like the law of cosine and distance formula, something like that, we need to memorize that for the final?
no, well, the distance formula, yes, law of cosines, no. Okay.
When you first find the radius,
Uh-huh.
so it's square root of 90 divided by pi.
Mm-hmm.
So it's the area divided by pi.
Well, we set it equal to the formula, pi r squared, and then we divided by pi, and then we extracted the square root to find r by itself. And so that's where that process led. Okay. All right, any other questions up to this point? All right, so what I'm going to do is I'm just going to rewrite this triangle a little bit larger. So here's A, B, and C. Okay, I now know that my distance from A to C I found to be that 9.45. Okay, if I know that arc BC is 59 degrees, then what does that mean this angle measure here, BAC, has to be? It's an inscribed angle. It intercepts an arc of 59 degrees. So it's going to be what? Half of that. So 29.5. Okay, and then here I can also look to find angle C. Angle C is an inscribed angle that intercepts an arc of 65 degrees. So what is angle C going to equal? It's going to be 32.5, right? Okay, so if I combine those together and subtract it from 180, I get my final angle measure B. So if I take 180 minus 29.5 minus 32.5, I get this angle to be 118 degrees. Okay, so now I've created this triangle that's of the pattern AAS or ASA. Okay? So in order for me to find the area of this triangle, okay, so now this is for the triangle, 1/2 my base of 9.45, and I want to find this corresponding height. I'll call it H. Okay, I can use either of these triangles, the right triangles formed with BC or the right triangle formed with BA, to find my height. I'm going to go ahead and designate it right here. So I'm going to call this Y. I need to know what BC is in order for me to solve for this height. Okay, so in my original triangle ABC, I want to find side Y. Can I do that? What pattern would you use? You have two angles and a side, AAS. Tells you you can solve by law of sines. So we can set up our law of sines. Y over the sine of the angle opposite it, which was 29.5 degrees. And that's going to equal the known ratio. So the known ratio is this 9.45 over the sine of the angle opposite it, which we found to be 118. And so now when we solve for y here, I can take my 9.45. I can multiply both sides by the sine of 29.5. So I'll go up here. Oops. That's an exact number, so I can use 29.5. Okay, and then I divide by this sine of 118. Okay, I have a decimal in my calculation, so it'll display it as a decimal. So I get 5.27 as my value for y. Okay, once I have this value, can I now solve for my h, my height of that triangle ABC? So now I come back inside here, and if I want to find this h, I have an angle, I have an opposite side, and I have a hypotenuse. Opposite and hypotenuse are related by what trig ratio? Sine. So I can say that the sine of 32.5 degrees is equal to h over the hypotenuse here, 5.27. So I multiply both sides by 5.27. That's going to give me my h value, which is what goes right here. Okay, so I can find that height. I can find it individually if I want to, but I'm just going to go ahead and calculate it in my whole area formula. I have 1/2 times the 9.45, so I'm going to go highlight that measure, times, and then just this 5.27 times the sine of 32.5. And when I hit enter, that is my overall area for that triangle. All right, so obviously you see that this in this embedded within this one problem is pretty much everything that we did complex in this chapter, right? Law of sines, law of cosines, trig ratios, as well as the different relationships between the sum of the angles in a triangle, as well as just those inscribed angles on the circle. You can see how long and complex the solution could be. It involves everything that we've potentially talked about.